Hello, my name is Pat McManus from the Siemens Designcenter product marketing team. Sketching is a key workflow in any CAD system. In this Designcenter how-to video, we'll look at ways to add more control to sketcher behavior so the designer has better control and understanding of the sketch behavior. The Designcenter sketch engine improves productivity by automatically finding and maintaining geometric relationships. This reduces the need to manually constrain every curve, especially in one-off designs. Some workflows, however, need more explicit control. This is important when a sketch must respond consistently across many changes, especially automated changes, where the user is not directly guiding each result. Examples include reusable design templates, master parts for a family of parts, and needs-driven studies that evaluate many, perhaps hundreds of parameter variations. For this demo, we'll use a C-clamp, where the base sketch is defined with dimensions driven by equations. You can see the main shape go through multiple configurations here, as various dimensions are driven to different values the way they might be in a template, part family, or heats run. To add a bit more complexity, we have added an adjustable boss to create a clamp such as one that might be used to hold lamps or other accessories to beams on the ceiling of a theater. If we review the sketch that defines the main shape, we see that it includes key dimensions driven by uniquely named expressions, making the sketch easier to understand, modify, and test across different values. Before we start, we'll review the sketch settings. In the 2606 release, some are familiar, some have been renamed for clarity, and some are new in this release. In customer defaults, the Sketch General tab can control whether the sketcher finds relations automatically by default or not. In session settings, we can choose to create persistent relations automatically and to add expressions for any new dimensions, and some other settings. Many of these defaults can also be adjusted in Sketch Preferences for the current session to turn them on or off. They can also be adjusted during sketch creation itself, giving users control at multiple levels. Now, let's see these options in a fresh sketch, first for clarity. We'll start with a new model and create a sketch on the front view. For the first example, Find Relations and Display Relations are on, while Create Persistent Relations is off. I'll create a 3-point rectangle, then place a circle at the midpoint of the top edge. The light blue indicators show found relations such as parallel, perpendicular, tangent, and midpoint. Hovering over the text and the sketch navigator will confirm that these relations are found and not persistent. If I turn off Find Relations and convert them, they become persistent and change to a dark blue. Hovering over these or looking at the navigator, you can see that these are now persistent. Let's undo this and try the other answer and see what that looks like. If I choose not to convert them by answering no, the sketch keeps only the curves and no relations. We can also manually convert relations selectively. If I right-click a found relation and choose Create Persistent, it converts only that relation. I can also use the Convert to Persistent menu from the Options pull-down and select multiple found relations and convert them at once. Next, let's look at relations created during dragging. With Create Persistent Relations off, I can drag a circle near a line and the sketcher finds a tangent relation, here shown in light blue. I can convert it manually if I need. With Create Relations turned on, the same action creates the tangent relation as a persistent relation immediately, shown in dark blue and confirmed by hovering text or the Sketch Navigator icon. Finally, let's build a sketch with the most explicit control. I'll create a rectangle and a circle with no relations. I'll trim the geometry to 4 curves, then use Make Relations to add persistent relations directly. I've turned the persistent relations on here. I'll do a parallel between the sides, perpendicular to the bottom, and tangent between the arcs on the right and the left. After adding radial and length dimensions, the shape changes correctly and is fully defined itself, but its position is still not. To finish, I'll dimension the center arc to the vertical and horizontal axes. Notice to get to the center of the arc, I select the arc, which highlights the center handle. Then select the axes and create 2 dimensions. I'll also add an angular positioning dimension. It's now fully defined positionally as well, and the sketch turns black, showing it's fully defined. Now, the dimensions can be varied, and the sketch will update exactly as intended by the designer. So now, let's take what we've learned, and maybe a new tip or two, and apply it to creating the sketch that will be the base for the C-clamp. I'll create a sketch on the front plane again, and start creating lines, starting with the upper horizontal. Now I snap a vertical perpendicular to that. I'm going to line the bottom one to the top, snap that, snap a perpendicular, another perpendicular, and a third perpendicular to that one. Again, I'm going to line to the end, and then I'm going to close out my section. The sketch shades to show me that I have a closed loop, and you can see that I now have a collection of found and persistent relations because of the settings that I've used. The verticals, horizontals, and collinears are found type, while the parallels and perpendiculars are persistent. I'm converting the collinear to persistent because I want to keep that. I don't, however, want the vertical or horizontal relations. So when I turn off finding, I'm going to say no, and those will get deleted, and what I'm left with is a collection of persistent parallels, perpendiculars, and collinears. Next, I'm going to continue adding additional parallel constraint relations on my own. With the relations done, I'm going to go ahead and create some dimensions. Starting with the span of the clamp, since I have the create expression setting on, it gives a default parameter name for the expression of P0. I'm going to change that to the word span so I can easily identify it. Next, I'll create a dimension for the throat and change it from the default of P1 to the word throat so it's also easily identifiable. Next, I'll continue creating additional dimensions, but these I'm not so concerned with tracking, so I'm not going to bother to override the default names. I do want to control the depth of the neck, so I name that one thick. And a couple more dimensions, and the shape is now fully defined. You can see if I drag it, the shape behaves as I'm expecting it to. So now, with the basic outline, let's create some blends in the corners. I'm going to show you a few different ways to do this. For the first one, I'm just going to create a 3-point arc, and you can see that it automatically applied tangencies and endpoint constraints. So all I have to do is put in a radial dimension there. Of course, the simple way to do this would be to just use the fillet command. It'll create, and I'm going to use the option to create it with the theoretical corner remaining. I can still do that simply by picking the corner and dragging it to size. I pick the option to keep the corner untrimmed so that I can identify it later. Now I'll add the radial dimension. For the third arc, this one is only tangent at the top and with the large radius, ending at the right edge, and the dimension end of that arc to the top of the span. The shape of the clamp is now fully defined, but the color is still not black because its position is not fixed and it can move as a rigid body. There are many ways to handle this, but for the sake of the example, I'm simply going to throw on a couple of dimensions relative to the horizontal and vertical axes. The color now changes to black, and the sketch navigator also confirms that I am fully defined. The final feature is to create the mounting boss. While that could be done in a separate sketch, I will add it here to demonstrate the use of work regions. I'll first turn off persistent constraints, then create a 3-point rectangle, a circle, and trim them, just as we did in the earlier example. Now I'm going to set a work region around these new curves. That way, nothing will accidentally interact with the previous sketch entities I've created. This can be useful when working with large or complicated sketches, even though we don't necessarily need it here. I'll turn persistent relations back on now, so I can add the exact relations I want by following the length and the width dimensions. The shape of the boss is now done, but again, it's free to float, so I need to make the entire sketch the work region again. And now I can create dimensions to position it relative to the other geometry. I'm creating 3 dimensions to do that, a horizontal, a vertical, and an angular. The final curve is the rotation axis of the boss, and now we are done with the sketch. You notice that I chose not to trim all the sketch curves back. That's certainly an option and is the way some users prefer to work, but I prefer to keep my theoretical corners and other construction geometry untrimmed if I can, in case I want to reference it later. But I can still virtually trim it as part of the actual extrude command or any command that uses the sketch. And this is also what allows me to include both features in the same sketch without them conflicting. I'll enter the extrude command, and I use the selection intent to tell Designcenter that I want to use connected curves, but that I want it to stop when it reaches an intersection, and I will tell it which way I want it to go. I can also tell it to automatically follow tangent connections when those are encountered. You can see that by starting in the upper right, it loops around the top, and then it asks me to pick the 2 curves that cross over the boss. After that, it automatically closes the rest of the bottom loop for me. I'm going to turn on the emphasis so that I can see the sketch curves that are inside the first body and select them, again, using stop at. And I create the revolve feature for the boss. As a final step, we're going to exercise some of the key dimensions to ensure that the template behaves as I expected. I hope you try some of these methods yourself the next time you need to create a template style sketch, and hopefully you will find that they help you achieve the result you're after. Thank you for watching.